on to the image formations. We are moving on to the image formations for convex lens at first. Convex lens. Image formations for convex lens at first. Okay, image formations for convex lens. Okay, let us straight away let us discuss it. First case, it is object at infinity. Object at infinity. So I have told you, whenever the object is at infinity, we will get what? Parallel rays will only come. F2 to F2, F1 to F1. Okay, at infinity means parallel rays will come. Here also 2 parallel rays. It will pass through the focus. Use your scale and pencil. I am repeating it again and again. Use your scale and pencil. It will move through the principal focus. So where will the object be formed? At principal focus. Are the refracted rays originally meeting? Yes, they are originally meeting. Okay, so if I keep a screen and if I adjust it backwards, when I keep the screen here, I will get an image of the object, whatever object, a big object, whatever object, I will get an image as a small image over there. So image is formed at F2, real image is formed, so it will be inverted and point sized. There is no doubt in that. And point sized. Clear? Okay. So this is the first case when object is at infinity. So now what I am doing is, I will take the object from infinity and I will keep it near to F2. That means beyond C. What? Near to C or beyond C we have discussed there. But here it is near to beyond 2F1. C means center of curvature. Here center of curvature is 2F1. Okay, beyond 2F1 I will keep it. Second case. So object beyond 2F1. Beyond 2F1. Second case. So what will happen? The object beyond 2F1, what will happen? The object is kept here. The object is kept over here. F2. One ray will be always parallel. Let us take one ray parallel. Straight line you have to draw. I may not be drawing a straight line, but you have to draw a straight line. And there should be arrow marks also. I am repeating it because you will forget to draw these things. We will forget all these small points in your exam, and that will cause your marks to reduce. So that's why I am repeating it again and again. Okay, so the parallel ray, it will move through the focus. And I will take the second type of ray. The ray coming through the focus, it will move parallel to the principal axis. I have taken the ray, the object beyond 2F1, where I have got it between F2 and 2F2, between C and F in the case of mirror. But here what it is, the image is formed between F2 and 2F2. That means C and F, between C and F. It is smaller than the object. Object was this much bigger, it is smaller. When you draw it in your book with the correct measurements, you will see the difference in the size. So it is what? Diminished image again. It is diminished, that means it is smaller. Diminished image. It is diminished image. Where it is it real? Yes, it is real. If I take a screen and if I adjust it in such a way that when I keep it at here, I will get the image of the object kept at here in the downward position. If I have kept the pencil like in the upright position, the needle of the pencil will be down when I see it on the screen. It will be inverted image, real image and inverted image. Is that clear? Is that clear? Okay. So now you understood. Whatever we have discussed it in the concave mirror thing, it is there here also in convex mirror also. Isn't it? Okay. So likewise you can find out all the image formations. I am not going to discuss it in detail because you can do it from home with using your NCERT textbook. So I will say when the object is kept at C, the image will be also at C. Image will be also at C For concave, so for convex lens, the image will be at C real, it will be real and inverted. And it is same size. It is same size at C itself, same size in the same case as before. And now if it is between F1 and 2F1, at C means, sorry, it is not at C, at 2F1, okay, it is at 2F1 before. Now if it is, the object is between F1 and 2F1, where will be the image formed? Between F1 and 2F1, the image will be formed beyond 2F2. As in the case before, beyond 2F2, it will be real, inverted and enlarged. This is the first case where enlarged image is formed. As in the case before, enlarged image. You just draw it, you use your pencil, you have drawn the image formations of mirror, so it will be easy for you. Don't worry about it, you will get it. And if you have any doubts further, you can contact us. Okay, so that is between, whenever we are keeping the object between F1 and 2F1, we are keeping it closer and closer towards the lens. Now the next case we can keep at 2F1. At F1. Again we are making it closer. So at F1, what will we get? I will draw it. At F1, I will draw it. Okay, so at F1, object or optic center F2 to F2. You have to take correct measurements. This is not correct for me anyway, but you have to take it correct. At F1, if I am keeping it, this is not. I am keeping the object at F1, parallel ray passing through the focus. The second ray I am taking it passing through the optic center. So this is a parallel ray going, isn't it? So this is a parallel ray going. So where will be the image formed? Image will be formed at infinity. It is real, it is inverted, because this is down from the optical center, from the principal axis, whatever is measured down, it is inverted. From the optical center, whatever is kept up, it is upright position, erect. Okay, so image is inverted over here, it is real, and what is there? What is to be found out again? It is highly enlarged. It is formed at infinity. Why it is highly enlarged? Why it is forming at infinity? I have discussed it before. Because we are imagining that from infinity a ray is coming. That means it is highly enlarged image. It is coming from infinity. So whatever ray is going to infinity, we will imagine that it will meet at infinity. So if we keep a huge screen at infinity, at a longer distance from the lens, and infinity means, I have told you again, this won't be 100 meters, 200 meters, 2 kilometers, 100 kilometers away. No, with respect to this small mirror, small lens, this will be at least, the infinity means it will be at least 75 centimeter from the lens, it will be an infinity distance for this lens. With respect to the lens, that distance is a infinity. That means it is a longer distance. Okay, so that is it. So it will be forming an highly enlarged image. And the last case here, it is when the object is kept between F1 and optical center. Okay, this is the only exceptional case over here where virtual image is formed. Till now 5 images formations were real. Now virtual image will be formed, and I will show you the image formations. I will show you the image formations when the school is reopened. From the lab we will show it. You will understand how we are arranging the screen. Then on the screen you will get what real images or inverted images with clear image. So you will be able to understand it more clearly. Okay. So this is F1 to F1, F2 to F2. Okay. So now what will happen here is, we are keeping the object here. So the image, one ray will be going like this, the other ray will be going like this. Okay, so it is what is happening there? It is diverged. That means it is not diverging, it is converging lens itself, but the rays are going, the refracted rays are diverging, isn't it? So it won't meet at infinity. So where it will meet? It will meet somewhere here. It will meet somewhere here. Okay, we are imagining that it will meet somewhere behind the lens. Okay, on the same side of the object it will meet. So it is not actually meeting. So virtual image is formed on the same side. On the same side, virtual image is formed and it is erect. Virtual images are always erect. It is erect. From above the principal axis it is erect. So virtual erect image is formed and it will be enlarged. With respect to the object, the image is an enlarged image. It's a magnified image. So it is enlarged image. Okay. So in convex lens, this is the only case where we get virtual image. In the case of concave mirror, the only case where we got virtual image was where? When the object was kept between the pole and the principal axis, principal focus, isn't it? When the object was kept between the focus and the pole, we got virtual image. Here, when we keep it between optical center and the focus, we will get what? We will get what? The erect or the virtual image is got. Okay, so this is the exceptional case. So be thorough with these things. The exceptional cases we have to be thorough. Where in convex lens, where we get diminished images, which are the positions of the object when we get enlarged images. In enlarged images, where we get real images, where we get virtual images, etc. It should be clear to you. Should be clear to you. Is that clear? Okay. Okay. So that is what you have to understand here. Now the same way. So now we have discussed the image formations of convex lenses. Now we have to discuss the image formations of concave lens. Here only two types of image formations are there. They are, whenever it is at infinity, we will get it at focus. Okay, so that thing I will draw. Whenever it is at infinity, we will get an object at focus. These are diverging lenses. Okay, these are diverging lenses. And here also parallel ray. I have told you only parallel rays will come. So where is the object formed? It is virtual. It is not real. It is virtual. Okay, so erect, virtual, diminished images are formed at focus. At f1. So when in concave lens, virtual image is formed when the object is kept at infinity. Okay, and the next case, wherever near to the image, whichever position we keep near to the lens, wherever we keep, near to the object, near to the lens, one ray it will be, okay, one ray it will be passing like this, and the other ray, if I take the passing through the optical center, you should draw straight lines. Okay, using your scale, you have to draw straight line. It is passing through the optical center. Okay, whereas the two rays should be really meeting for a real image to form. But here both the rays are not real. One is imaginary ray, virtual. So here also virtual image is formed, diminished image is formed, and erect image is formed. Okay, and all will be between f1 and optical center. All the virtual images will be between f1 and optical center when it is near to the mirror, near to the lens. When it is at infinity, it will always be formed at f1, virtual image. Here the virtual image will be formed whenever, if we keep it here, wherever we keep the object, the image will be formed between the f1 and optical center. Is that clear? So in concave lens, what you have to understand? In concave lens, what you have to keep it in mind? In concave lens, what you have to keep it in mind? In concave lens, you have to understand that always virtual image is formed. But there in mirror, convex mirror was forming always virtual images. And also in concave lens, it is always diminished images formed. Isn't it? Okay. So here you have to again note the sign conventions. So we know the sign conventions. This is the optical center, means towards the right hand side whatever we measure it is positive. Towards the left hand side whatever we measure it is negative. Above the principal axis it is positive. Below the principal axis it is negative. Okay. Here real images. For real images what will be the value? Will it be positive or negative? For real images, will it be positive or negative? Will it be positive or negative? It will be positive here. Before in reflection it was negative, but here it is positive. Because always you just note down, means what? You just imagine the real image formation. It is always on the right hand side. So it will be positive. And inverted image, what will be inverted image? It will be always negative. There is no doubt in that. It will be always negative below the principal axis. Erect images, it will be positive. Isn't it? Virtual images, here for virtual images it will be negative because it will be on the left hand side. Okay. Then height of the object, here height of the object it is positive. Height of the image for real it is negative because it is inverted. For virtual it is positive because it is erect. Above the principal axis it is positive, below the principal axis it is negative. So these are the sign conventions which we want to use when we study or when we do the problems, the numerical problems. We will be solving a lot of problems in this chapter. Okay, so then you have to understand these things. Now we have to study lens formula. We have to study lens formula. As we studied mirror formula, for our calculations we have to discuss lens formula also. So lens formula, 1 by f, 1 by focal length is equal to 1 by v minus 1 by u. U and v you know, image distance, object distance, etc. Okay, 1 by f is equal to 1 by v minus 1 by u. Okay, is that clear? So this v, real image, for real image the object distance will be here positive. I have told you before, object distance will be positive here because it is always formed on the right hand side of the lens. Refraction happens, isn't it? For image distance v for virtual images will be on the left hand side, so it is negative. But in the other case it was just the opposite in mirror. Okay, don't confuse with that thing. You understand the concept, that is the important thing. You understand the concept, everything will be clear. Okay, so 1 by f is equal to 1 by v minus 1 by u. Before it was 1 by v plus 1 by u. For mirror formula it is 1 by v minus 1 by u. So this will be the lens formula. And magnification, as we have studied before, magnification value, m is equal to height of the image by height of the object. That is the same thing here. Magnification, what is magnification? You know, it is the relationship between height of the image and height of the object. So hi by ho is same over here. But one more thing, it is v by u. Before it was minus v by u. But if we want to do the calculations and if we want to connect the height and the image distance and the object distance, etc., we have to use this formula. So here it is not minus v by u, it is plus v by u. Okay, that is the difference there. So magnification also it is clear to you. Magnification is equal to height of the image by height of the object, and that's equal to v by u. Is that clear? Okay, so these are the things to be noted down when we are discussing this chapter. Okay, and one more thing to be noted down is, the last point in this chapter is the power of a lens. We are using specs. Some of you are using spectacles for reading and all. You may have some defects. You cannot see far away objects. You cannot see nearby objects. Some of you cannot see nearby. Some of you cannot see far away objects. So according to our vision, the defect in our vision, our doctors will be prescribing a lens for you, the specs. isn't it? In the specs you will be having a lens. That lens, how they are calculating the power? How they are calculating the power? Using this lens formula, they are calculating the power. And for calculating the power of a lens, for calculating the power of a lens, okay, for calculating the power of a lens, what we have to take is, we will take the reciprocal of the focal length of that lens. Whichever lens we take, if you want to calculate the power of that lens, you just find out the focal length of that one. Find out the focal length of that lens. Okay, and the focal length, if it is 10 centimeter, what you have to do is, if you want to calculate power, this 10 centimeter, if it is in 10 centimeter, first you convert it into meter. For calculating power, always convert the focal length into meters. So 10 centimeter means it is 0.1 meter. Isn't it? 10 centimeter, which is 0.1 meter. That means 1 centimeter is equal to, 1 meter is equal to 100 centimeter. So 10 centimeter is equal to 100 divided by 10, that's equal to 0.1 meter. Okay, so this 0.1 meter. So what do you have to do? Okay, so F is equal to, you will got 0.1 meter. Okay, so this power is equal to 1 divided by 0.1 meter. This is how you have to calculate the power. Okay, so if you get the focal length in centimeter, you convert it into meter and then you calculate the power. Okay, so taking the reciprocal of the focal length of any lens, you will get the power of that lens. If you calculate the reciprocal of the focal length of any lens, you can calculate the power of the lens. But keep it in mind, the focal length should be calculated in meters. Then only you will get the power correct. Okay, and the SI unit of this power of the lens is diopter. The SI unit of this diopter. SI unit of the power of the lens is diopter. That's also you need to keep it in mind. The SI unit of the power of the lens is in diopter, and whatever the focal length of the lens it is, if you take the reciprocal 1 by F and that F should be in meter, then you will get the power of the lens. And that power of the lens is calculated in diopter. And if your friends are going to the eye specialist and all, they will be prescribing the lenses. It will be minus 0.1 D plus 2.6 D. That D is this diopter, which we have discussed before. Okay, so these are the important points to be noted down. Understand the concept of reflection, refraction, the image formations of mirrors and lenses, refractive index, the lens formula, mirror formula, magnification values, the power of the lens. So these are the important points in this chapter. So study all the concepts. After that, we can do more problems. Okay, so after doing the problems, you will be very much thorough with this chapter. I hope everything is clear. If you have any doubt, you can contact at any time. We teachers are ready for you. Okay, so stay safe. Thank you.